Hey, 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 Workflow Wednesday is underway with none other than, as you guys know, maybe you don't know because you're new here, Fusion Phil here at JitCAD Cam. This week, we are changing things up again. Now, we've done this a little bit over our time. We wanted to give Workflow Wednesday a little bit of a rebrand. If you guys haven't seen, is looking more in depth at things that are plugins inside of Fusion. In this case, this week, we are actually going to review some things that does involve Fusion, but it's more talk about the machines than it is actually creating and generating toolpaths inside of Fusion. If you guys are new here, welcome, welcome, welcome. As well, all of my returning viewers, as always, we're happy to have you here. Now, I do have to say, if you guys have any questions at any time, feel free to throw a question in the comment area. If you're watching this at a later day, feel free to, I should say, not comment area, live chat. If you're watching this at a later date, feel free to throw a comment down below or use the emails down in the description of this video. Send us an email, put in a support ticket as well. So, with no further ado, I think it's time to kick this off. So I'm going to go ahead and I'm going to share my screen, and we are going to start off talking in Fusion, and then you all are going to see my absolute horrible skills in Excel. However, the whole goal here is to get the point across. Again, I want to remind you guys that if you are somebody looking at a new machine or looking to maximize some of your efficiencies, you can reach out to us directly for a more one-on-one scenario. Now, the idea of this video and why I'm doing this is to break down if you're adding a new machine or you currently have machines or you're looking to purchase your first machine, where I would put my money, options I would get, as well as upgrades along the way that all base themselves around making parts. So let's kick this off. As you guys can see right now on my screen, we're dealing with a part that is utilizing kind of two different systems. And I say that because the very first thing we do is we have a lathe setup one on this part. We do our OD turning. Now, this isn't completely actually machined out, but the idea is that you would then flip that part over and machine the backside. And then your third setup is going to require turning around and putting this on a fourth axis rotary to drill all your holes around the outside. And then lastly, we're looking at a fourth setup, of course, to stand the part upright and come in and do the milling of the additional areas as well as the drilling. Again, full disclaimer, guys, I don't have all the toolpaths here. The idea is to give you a real world scenario of a part, in this case, that is requiring 4 setups to get it done. Now, if we transition from 4 setups, and by setups, you guys are going to notice here, although I have 4 setups in Fusion, the idea is you are having to do 4 separate setups, whether it be 2 setups on the same lathe, 2 setups on the same mill, things of that nature. Pivoting a little bit, our second scenario, as you guys might be able to see here, is I've labeled this as mill turn. So again, this time round, we're doing everything on this part based on having something like a live tool lathe with a Y-axis. And then just so happens that same exact machine also has a sub spindle. And with that sub spindle being able to pivot and do everything on the back side of this part, for those of you that are critiquing me a little bit, it would look a little bit more like this because the part would be, again, in the sub spindle of the machine to face off the backside. So this is where we are going to shift gears, and we're going to look at how well I can put together a spreadsheet on the fly for you guys to look at what scenario might be better for you and what other machines or kind of workflows we can look at. So me personally, when I make a decision, not necessarily about a machine, but this could also be how I am going to machine something. Some of you have the luxury of having mill turns laying around at your disposal. Obviously, if you have one, running this part in the mill turn might be a good idea, but I'm going to give you a few scenarios as to why it's not. Now, if I'm going to break down a part, what I like to think of at the end of the day is you have the initial setup, right? So let's go ahead and say initial setup. And this is things like your jaws, getting your jaws bored out, anything that's going to be involved in holding that part. The next thing I like to think about is you have what would be referred to as the cycle itself. Now, we do need to worry about, in the world of milling, Later, what's going to be referred to as tool changes. And then lastly, what I like to actually look at is an additional thing is this is going to be anything that's involved around the part handling to swap out the parts, right? As I'm going to say is we are just going to do a part exchange. Again, this is part loading and unloading. That actually is a little better term, part loading, right? So from when the cycle stops, you have to load the next part in and hit cycle start again, right? So these are factors that do play into quite a bit of different things when we talk about efficiencies. So what I'm going to do now is we're going to go ahead and say this is our lathe 1 and then lathe 2, followed up by mill 4th axis, and then lastly a mill 3-axis type of thing. So again, we could walk through these and do our setups. Let's say, for example, we got 20 minutes into making some jaws, another 20 minutes for jaws for the second one. The 4th axis on the mill, again, let's just keep the numbers pretty straightforward, right? So let's just, across the board, put that time out there. Now, our cycle time on the first side of our lathe part is probably going to be a little faster. Let's just say it's 5 minutes. Our secondary lathe operation, when we flip it, is going to be closer like 2 minutes. And then we have to go to our mill. We're rotating our A-axis, doing a bunch of drilling. Again, let's say we get closer to a 4-minute cycle. And then lastly, dealing with a 3-axis mill, this cycle might be the worst of it all, where we're looking at something like a 10-minute type of scenario. Now, again, we're dealing with the idea of a operation that cannot be stacked with multiple parts. We'll look at that here in a moment when we start to talk about pallets, working with tombstones, things of that nature. So our tool change time is across the board just going to be nothing more than 0. Now, part loading, again, this is the time it takes somebody to open the door, retrieve the part, place a new part in, and then again, basically hit cycle start all over again. We're going to be a little generous here. Let's say it takes 2 minutes, 2 minutes, and then a little bit more time on the 4th axis. And lastly, on the 3-axis, we're back to 2 minutes. So this is something I play out in my head very quickly to understand what it really takes to make those parts. Again, what I'm going to do is we're going to go ahead and put a quantity up here. And the idea of the quantity is going to be everything we do from this point on is going to be a multiplier, right? So as we know, regardless of how many parts we do from 1 to 1,000,000, our setup's never going to change. So we're going to go ahead and throw in the good old fashioned, we want to sum everything across here. Now, for some of you out there, you're probably wondering why it is that Fusion Fill uses Zoho. It just so happens it's what I have available for spreadsheets. So then we have our cycle. So I'm going to go ahead and grab this and I'm going to drag this down. And then with that, we're going to actually modify each one of these equations because we need to multiply that by whatever our quantity is, which is going to be in this field right here where I failed to put a number. So let's go ahead and type in the number 1 and make sure that works. As you can see, we have 21. If we go ahead and put in the number 2, 42, the multiplier is working. And again, we're going to go down a little bit further and we're going to do that one more time. So again, we're going to times that by that C1 category. And for the sake of this part, we're going to go ahead and take this guy as well. And we're going to go ahead and multiply that one also by that C1. So the idea here is if the quantity of parts jumps up by 10, as you can see, we're seeing a cycle time increase pretty dramatically based on our total machining time, right? So again, our part loading time overall goes up as well. So we're starting to spend a lot more time handling parts. So let's break this down all over again, but this time we're going to go in and we're going to say mill turn main and mill turn sub, right? So again, our initial setup on the main is going to be comparable to our lathe. However, I am going to increase this a little bit because you do have things like live tooling. And then again, our cycle time is now going to be incorporating multiple things. So let's say we have that 5, the 4, and the 10. That's going to come out to roughly 19 minutes. And then our secondary operation is going to be back to that 2. Going down a little bit further, we still have a 0 across the board for our tool change times because again, we're not running more than one part in a cycle start scenario, always in multiple of one, right? So lastly, we're going to go back to part loading. And again, this is going to be dramatically reduced overall. Now, it's very hard to know what that is going to be. A guesstimate in my head, if you're loading a slug and removing a slug, is it's going to be a comparison of what lathe 1 and 2 are combined. Again, we're going to go ahead and type that in as 4. And again, follow that up with a 0, right? So we can now rinse and repeat what we've already done. We're going to look at this from a standpoint of equals sum. Again, we need our 2 setup times put together. And then from there, we have our equal sum. And then we're going to take our 2 here. And then again, all over again, we're going to multiply that by C1. Now, some of you out there with the advanced Excel spreadsheet skills are probably going to tell me that you do have that ability to use dollar signs to lock out input fields. But for this sake, again, we're just going to make it the easy way of typing in the word sum. It also gives me a chance to BS you guys as much as I can here. So again, sum is going to be category 1 and 2 times C1. So what I'm really trying to get across is show you guys that, one, I can't apparently type these numbers in because I'm not holding shift. So let's fix that. Is looking at nothing more than a time study of adding nothing more than that mill turn machine. What are we going to achieve? Well, presumably overall, we have now saved 50 minutes of somebody touching parts, right? And this is a big deal at the end of the day, is how much your hands are on a part will determine your profitability at that company, right? So what we've done is, even if one guy is jumping from machine to machine to machine to machine, stacking these parts, is we've already reduced about an hour's worth of time out of the box. Now, our cycle time in this case, as you're seeing, we haven't really seen a dramatic difference in cycle time, and we have seen a little bit better in setup, but this is based on a 1-to-1 scale. Now, this is where there's a lot of controversy at the end of the day when we talk a mill turn, which is just a live tool lathe, versus a B-axis lathe. Depending on the material and what you're machining, a lot of those mill turns are limited to maybe 4,000 to 6,000 RPMs. Where if you're running aluminum, in this case, my mill might be looking at like 10 to 15,000 RPMs, right? So this is, again, one of those scenarios that, based on the machine spindle, which is the whole point of this video at the end of the day, is this can dramatically increase your cycle times overall. And again, turning something like a mill turn machine, although it can run with a bar feed unassisted, into actually being the polar opposite of jumping between, 2 lathe operations into 2 mill operations, right? So let's say, for example, I'm just going to use a factor of 2. We're going to add another 4 and another 10. So let's go back into here. We're going to add 14 minutes onto that. Let's go ahead and put it up to, let's just go 32 minutes, right? So again, because we've seen something as simple as an RPM difference between these 2 machines, we've automatically now dramatically increased how long it's going to take to do these parts. And if you guys out there are wondering from a scheduling standpoint, yes, we could simply say equals sum, and then I could grab all of these categories. This is going to give me my total time. Oh, let me go ahead and do that one more time. So it's going to be 440 minutes worth of running, right? That's tying up one machine, the capacity of that machine, for 440 minutes at the end of the day. So this is a really good thing to break down. And again, I could rinse and repeat that one more time. We're going to go ahead and say equals sum, grab all this data. Now, the big difference here is we're looking at a singular machine creating a singular part. A different scenario is we're looking at 2 machines. Let's say you're lucky, you got the table width for a 4th axis and a 3-axis chuck there. We could actually, again, reduce this down a little bit more, but now we're only occupying 2 machines, which in theory, a lot of times will get your parts done faster, and it will help with your overall time and how quickly things are leaving your shop. So this is a very unique case when we talk about what would be referred to as a mill turn machine. I'm going to throw a third scenario in here now because That first scenario that we did with everything, it's very comparable to what happens if you have a B-axis lathe. Now, a B-axis lathe does give you that ability to look at utilizing a lot more RPMs. Those RPMs are valuable when it comes to machining, again, softer metals, or having the ability to have torque as well. One additional thing I'm going to point out here as well for a lot of you, if you guys don't know, on a mill turn machine, it does consist of having tooling that needs to be rebuilt I think it's every 4,000 to 6,000 hours of runtime. So that being said, is you have to rebuild tooling. You have to make sure that you have enough pockets in this machine to hold all of your tools. Again, why I tell most people is you should be looking at a B-axis lathe like a Multis or an Integrex or an SMX. They are all great machines, but you're getting a milling head on that actual lathe. So we're going to go ahead and we're going to go back one more time. We're going to pull back open my Fusion. We're going to look at a little different scenario. Let's talk mill this time around, right? So on the milling side of things, as you guys can see, again, a nice scenario would be the fact that I have a setup for the first setup of a part and a second setup of a part. Now, again, the idea is we are running both of these in the machine. And let's go ahead and get everything turned back on so we could look at it. Give me a sec here, guys. I went ahead and did the number one thing, which was toggle everything off. But what we're looking for is to see all of those parts. Go ahead and get that turned on. And we should have a vise in here somewhere as well that's just not turned on. So again, this scenario is a little different when we talk about tool changing, because in this scenario, we're running two separate setups versus multiple parts. But tool changing does take a factor and it does limit you. Another thing we're going to talk about here is what happens if you were to go to a fourth axis and be able to machine multiple sides of a part. So again, this is the fun of utilizing nothing more than a spreadsheet to walk back through that scenario and see what it is that it's going to take. Now on our mill parts, we know that's going to be 0 for the lathe operations. And as you're going to see now, when we look at the milling, let's say we're going to go 3-axis and 3-axis. And with that being said, our initial setup, 10 or 20 minutes into 20 minutes is fine. Our cycle on the first part, let's say it's closer to 15. And then after the fact, we're closer to 12. So again, we now can account for tool changes in the event we're going to run what I would say the same part multiple instances. And if you guys didn't know what that is when we look at side of Fusion, is when you create your setup, let's say I'm going to run 6 Kurt vices and we're going to do the same setup 6 times, right? So when I go in and I say I want to run 6 of these across the board, and then I have the ability to change my operation order to utilize by tool, meaning we now save a tool change every time on those 6 parts, right? So the luxury here is the idea is we are going to get a diminishing return on our tool changes, right? So again, if we go into tool changes, and let's just say this is something that we're going to spend about 2.5 minutes worth of tool changes on. Again, our setup 2, we're going to go ahead and plug in 2.5 as well. This is where it's going to make a difference, which is a little tricky always to do the math, because as we initially did, we multiplied that by a quantity. However, in the event that you're running the same part with multiple instances, when we start to talk about jigs, fixtures, mighty bites, pallets, things like that, this doesn't actually need to be multiplied by that same number. What I like to do is I like to start a secondary cell, and that cell is going to be where I put in my factor, right? So if I put in a factor of 1, meaning we're going to run, in this case, let's go back to that idea of 6 parts simultaneously. However, the number of tool changes when we add instance 2, 3, 4, 5, and 6 doesn't change. So that time can actually still stay the same. So again, as you guys are seeing, is depending on how you're running these, is again, if we up the ante there, again, if we try to complete one part and jump from one to the other, you're going to see quite a bit difference at the end of the day. So I do see my first question in here. Not tonight. What's going on, buddy? Toolpaths save out as per a tool change. Yes. So one thing I was pointing out there real quick, not to get too sidetracked, is If I go operation order by tool, it will stay with the same tool until it is done with all operations using it in the specific pecking order. So a good example here is tool 1. We would stay with tool 1 until all the facing was done. Then we would go to tool 2. We would rough contour each part. Again, jumping from 1 to 1. Awesome. So great information. Again, great question, guys. I love the questions. Keep them coming. But the idea is to continue to look and kind of understand is what is the better bet when it comes down to these different scenarios, right? We're going to go ahead and take a step back here because now what if we look at a part, and this is something I like to do. I think it works really, really good at the end of the day is if you do this in design, it actually doesn't change anything on the other end on the manufacturing side, but you have what's called accessibility analysis, right? So when I want to look at a part and determine, am I going to make that part or am I not? I'm going to go ahead and get everything turned off is we could start by looking at accessibility analysis. Again, this is a valuable tool when we consider is actually that's minimum radius analysis. I can go back to accessibility analysis. The nice thing is when we start to talk about 3, 4, and 5 axis milling, as you guys can see, is anything in green right now is achievable by that one independent direction. That means anything in red is considered undercut. But if I have a flat end mill at the end of the day, there's going to be a couple caveats here because we can't make square corners, as you guys know, is I can utilize this to start to get that understanding is if I mill everything this way, and then I flip it over and I mill everything back the other way. And then lastly, what happens if I do a whole new direction of the top? This is a scenario where I like to start to think about looking at a part from 3 sides and 3 sides when we talk about 4th axis machining. A little better understanding about that is I'm going to go ahead and use this part as an example. Is if I go and update my appearance here, is again, I know this part is aimed much more at the end of the day. We're going to talk about this in a 5 axis. But let's get a couple of colors on here. We're going to go ahead and update the faces, and I'm going to use blue and green, right? So as you can see, if I start to apply color to certain items, we have green here, and green here. That on a 4th axis is all reachable. Now, again, guys, this isn't the most expert part for showing this example. But if I turn around and then go blue here, say blue here, and blue here, lastly, I'm going to put blue on the bottom. You're starting to think about how a part rotates around center. What can I get and what can't I get? Now, it would not be ideal if you guys are judging my machining abilities. Would not be ideal right now to hold on to this part here and try to machine upwards at it. The idea is nothing more to think that we could rotate that part, get side 1, 2, and 3, even though there's additional angles, and then possibly 1, 2, and 3, right? So again, when you make that decision to jump into a 4th axis machine, now a lot of people out there, I don't know why it is, they are just screaming to go all the way to 5 axis. And that actually reminds me, let me pull up another part that would show this better. So again, we're going to go back and where is my favorite part? Where's the enclosure? Give her a sec here. Nothing more than the simple enclosure to save the day, right? So the idea is again, I'm going to go ahead and modify the appearance here as we just did, but let's go ahead and apply to faces. So let's say we got blue, blue, and blue. Guys, let me know in chat. Does this look much more understandable? Point I'm trying to make. So again, we have green, green up here, technically, green here. The pocket would also be green. But the idea is again, is if you were machining a part like this right now, there is what I would consider 5 sides to machine. Now, how do I get 5 sides? Well, you have 1 here, 1 here, 1 here. 2 of these are duplicated. That's understandable. You have a 4th one and a 5th one. We do luck out on the end of this part that there's nothing there, but the idea is still the same. Is any way I can align and think about a part in getting 3 different angles on it. This is where a 4th axis just saved me 1 setup, 2 setups, again, a 3rd setup, 4th, and 5th. Not necessarily in that order, of course, right? So the idea is when you're looking at getting a machine or talking about getting a machine is if we go back to that amazing spreadsheet that I built out here and we start to talk about utilizing a fourth axis. Now this could be a mill turn. This could, or not a mill turn. I apologize. You could make this part on a mill turn. This could be something like a horizontal or just a simple A-axis rotary, right? So again, you might spend a little bit more time on setup in that scenario. And then from that, our cycle will also go up a little bit. However, when we start to utilize the reduction in setups, I'm going to say that reduction in setups, we have modified and started to change and pushed a lot of those tool changes off into the very first setup, doing 3 sides, things like that is your advantage. We're also reducing part loading. I guess I should have built this out a little better for you guys. We should have kept one as 3 axis, and I think that's what we're going to do. We're going to talk about total time at the end of the day now is, again, let's say across 5 setups, I'm invested 45 minutes. Now, cycle time total for, 5 setups, let's just put it a little closer to 22. Tool change time might be, much higher because, again, each setup requires those tools to be cycled. And then, in a perfect world, let's just say we're still using 2 minutes per swap out, 5 total cycles. As you can see, we've now built out kind of a little better time study. Going back to the other scenario, my setup could be reduced. Depends on your jigs and fixtures, right? Because am I using Mighty Bites and building custom jig plates? Or am I putting this in something like a dovetail vise that we have over here? Again, these are factors to consider. But when we look at, again, getting into that world of a little bit more production machining, for you guys out there making onesie twosie parts, man, you're wasting a lot of time watching this particular video. But again, our cycle time as a whole, presumably spindle to spindle, tool to tool, is probably still the same. Our tool change time is going to be reduced. Remember, we can rotate the A-axis to get to different areas. And then lastly, my part loading time, although would be a little bit higher than a single setup, because we are doing 2 setups, right? We're going to keep both parts in the machine. I'm going to flip from one to the other. Whatever the scenario is you build out, the idea is still the same, that's how we want to utilize everything to get an understanding of, is it better to go 4 or is it going to be better to go 5? Because I'm going to go ahead and sum these up here real quick. My favorite thing ever. We're going to take these 3. Nope. And then we are going to add in this guy here. I'm missing one. Okay, so what we want to do is we're going to throw another set of brackets. Guys, don't judge me. And then we are going to take whatever that is times that C1 number. And again, we're going to move this over 1. And then quick tip here, we're still utilizing, oh yeah, it didn't update. So we got to go back to D. And one more time, we want, there we go. Oh, bad value. All right, what do we got here? Oh, duh. So again, we're getting about the same amount of time at the end of the day. Now, that is all based off a 6-part scenario. If we up the ante even further, let's say we go 20, our times are staying the same right now because I built my expression wrong. But it still goes back that we should be seeing a reduction. I think I did build my expression quite terrible. Actually, for some reason, we duplicated the same expression twice. Let's just do this the good old-fashioned way. Trying to get quick with my Excel spreadsheets and just not happening. And we're going to take that times 1. Of course, I clicked out. And we're going to lastly add in our setup time one more. Good news is, guys, you don't have to waste your time doing all this fancy spreadsheet stuff, because in the event you guys were using Scrap Shop Management Tool, it would do it automatically for you. Another way to look at something like this is with the Haas machine, or not Haas machine, the Autodesk machine connector, which we have a ton of videos on. Go check those out. So the idea now is when we look at a production schedule, and I'm breaking this down to, we have 5 vices in the machine, setup 1, setup 2, setup 3. You're just daisy chaining these down every time you push cycle start, right? Which might reduce our tool changing a little bit. But the idea is still the same, is when we start to look at the total numbers as how long that job is going to take, it has dramatically, again, reduced itself all over again. But what do we do in a scenario where our part loading actually starts to be a problem? A fourth axis mill can be exactly that. Let's say, for example, I'm running 30 parts and each part has a mighty bite, right? Now, all of a sudden, your part loading time has changed to 20 minutes because all the effort you have to do with that machine sitting still at the end of the day. Again, this is 20 minutes here times 20, right? Actually, we wanted to do 20 parts, so that would make sense. Let's say we bump this up to 100. So again, now you got 20 minutes of time to change out, 20 parts, right? Again, these are all factors that play in quite a bit at the end of the day to give you guys a much more efficient machine. That's why we recommend over here is like when you see a reduction in part quantities, you tend to see a little bit faster cycles. Now, again, this is all based off the idea that you're there 8 hours a day. You guys tell me, would you rather stand there for 20 minutes swapping out a bunch of parts so that machine hypothetically, let's see here, we're going to run for about 25 minutes, and then you're going to spend about 20 minutes changing out parts. Is that beneficial, right? Technically, our cycle time would have went up here quite a bit by adding more parts. Let's use the number 10, right? Let's just say 22 turns into 220. And then hypothetically, this number needs to be... Oh, we're zooming in here. Let's zoom back out. This number would be divided by a quantity. Because again, we've now gone from running 1 part per cycle to running a quantity of 10, right? My fingers are not working. Okay, so we're going to take this guy and we're going to divide it by 10 because that's the factor, right? So again, we can, every time we push cycle start, we're getting 10 parts, hypothetically, right? So the idea, again, is although we're now spending 50% of our spindle time just changing out parts, there's an advantage to this. If you're a one-man shop or a small shop, is we are going to keep that machine running as long as possible, right? So again, the idea would be is let's say we up the ante from a factor of 10 and we go to, I don't know, 20, 30 maybe. Actually, we're going to fix my spreadsheet. I'm going to show you guys how. So let's go ahead and delete that. We're going to go back to a 22-minute cycle. We're going to add in another number here. Actually, we're going to steal this number. This is going to be parts per cycle, PPC. And what we're going to do now is we are going to take that lovely 22 and we are going to times it by whatever that number is. Oh, times this guy. You know what I'm not doing? Putting the equal sign. There we go. So again, whatever this number becomes, just to show you guys that we're still an honest person, we go 10. Now this guy down here needs to be divided by whatever that number is as well, just to get our numbers back. So again, let's say we go from 10 to 20. It makes more sense because now we're running for a lot longer at the machine and our part loading time also is going to go up. However, the machine stays running even longer. That's the key element that I want to show you guys. This is the luxury. And I'm speaking primarily on the idea that you're loading, let's say a plate of Mighty Bites. You're using a axis on a vertical, right? You don't have a pallet changer to pull in a different tombstone. But the math goes back to the same, is that's why we start to talk about is do you do something that's going to be a horizontal machine? Or do you start to make like mini pallets? If you guys haven't seen the quick change fixtures or being able to set up even your dovetail fixtures with a quick change so that instead of you wasting a ton of time putting in a bunch of parts, you can actually turn around and just swap out the entire plate. So again, going back to kind of the math here one more time is we would see a reduction in part loading because we are now not loading the parts in the machine. We're loading them on a pallet and swapping out the pallet, if that makes sense. So again, this is where we start to see, again, a lot of benefit at the end of the day, where in my personal opinion, before I let you guys go, you guys are going to have to tell me if you like this video in the comments. I see almost nobody showing up into the live feed. I love it. Lets me know that when I do these interesting workflow Wednesdays, nobody really reaches out. But going back to my original goal here is I wanted to let you guys know, I say it a lot. If you guys have ever met me, I see companies making fortunes on Fidels, and I see companies losing fortunes on, brand new DMGs. It's not DMG's fault. It's the lack of planning and understanding of a good manufacturing method, right? Again, the goal is to get the spindle moving. We do want the spindle to move efficiently, but there is a time where you'll find yourself, and this is very common, is taking more time to swap parts than actually machining parts, and how you can remedy that, right? Again, one more thing I would remind you guys about is when you start to look at a mill turn machine, there's a few factors that we always make people aware of. Live tooling needs to be rebuilt. The more tools you put in there, the less pockets you have, and the smaller your work envelope gets. And that's, again, why I've seen a lot of shops on some TM1s and 2s with a TL1 or 2 lathe absolutely rocking and knocking things out of the park versus somebody that may have invested in a live tool. I'm going to pick on Haas. I'm good at picking out Haas. Is a ST30Y with sub spindle arrangement. Again, the low intro cost to get on those 2 machines goes back to, a bird of the hand is worth 2 in the bush or something of that nature. But I'm going to let you guys back to it. I already see Vincent out there bragging it up about his 4th axis Mori. That's awesome. Swaps out pallets in virtually no loading time. 100%. That is a big part. Marcin, great to see you here as well, guys. Again, let me know if you guys like this content. Feel free to hit the like button. Leave a comment down below, even if it sucks. I'd love to hear if you guys don't even like this content. But as you guys know, it's not what you know, and who you know is Fusion Phil over here at JitCAD Cam. That said, we will be back on Friday for yet again another free support Friday where you have full range over submitting tickets to us, getting your answers real time, and even trying to stump the chump or getting your setups roasted on the fly. Thanks, guys. I hope you have a great rest of your day. Look forward to seeing you on Friday.